Buongiorno a tutti, come già preannunciato dal dottor Triulzi vi darò alcuni...
Good morning to you all. As it's been anticipated, I'll present some preliminary results concerning the use of potassium polyaspartates in connection with wines. Now, the interest when it comes to additives for tartaric stability is to come up with effective products that perform well and that can meet the need for a reliable additive for winemakers. So they have to be good stabilizers, but at the same time they should not interfere with the colloidal structure of the product, and they have to preserve their action and performance in the course of time. These are the aspects that we have assessed during our experiments. There were many experiments, and these slides are just a summary of some of the tests that we ran or have been running in the past 2.5 years. They are largely based on red wines, where the interest in using these additives because generally stabilizers interfere with the complex colloidal structure and the color. One such experiment was carried out on dolcetto, and it was a combination of metatartaric acid and potassium polyaspartate at the same dosage of 100 milligrams per liter. After this addition, the wine was bottled in the days after the addition of the adjuvants, and then it was kept for 1 year in a bottle in a thermostat or a temperature-controlled room at 20 degrees C. We also carried out a quick stability test, but what we were interested in was to observe wine behavior in over a long enough period of time to see what response the wine would provide. Now, these are the tests of the product 2 days after the addition of the adjuvant, and the assessment was performed using the two traditional tests, for us cold tests, which unlike literature tests that suggest 6 days at -4 degrees, which were actually the conditions that we adopted, that we chose, was also evaluated not just because of in terms of a visual assessment of the presence of crystals, but also led to an analytical assessment of tartaric acid concentration. And that was achieved by filtering at 0.45 with a 0.45 mesh. The bars in red are a variation on the mini contact test that measures the conductivity at T0 and T10 after the addition of 10 grams per liter of micronized potassium, and it studies secondary crystallization after primary crystallization has taken place. Now you see data on the replicas. The central bar is similar to that of metatartaric acid, the one in the center being potassium polyaspartate. Now, this response was assessed over time. As I mentioned, these are the results of the cold tests repeated every quarter for 1 year. You see in red the response to polyaspartate, and metatartaric acid is in green. So after 3 months of cellaring, metatartaric acid is losing its efficacy. So our product kept perfectly efficient over 1 year of cellaring. This was also confirmed in the screening with different products, all of which kept stability very effectively over 1 year. Polyaspartate is a polymer of N-aspartic acid. So we assessed free aspartic acid with HPLC, and we just measured, we just added very few milligrams per liter in all the samples. And we measured the increases, which are just a few units of milligram per liter, which is just an indication of the stability of the molecule which is added. The other parameters that we analyzed were the color intensity. Throughout the cellaring period, there's a natural tendency to a reduction in color, a decrease in color intensity, but again, both for metatartaric and for polyaspartate, the same intensity was kept as that of the control. The same applies for color hue, as well as loss of anthocyanin, which were measured using spectrophotometry. They decline over time, but their decline doesn't seem to be affected by the loss of product. So the three endpoints that we considered were the following. First of all, that polyaspartate is comparable to metatartaric acid in terms of efficacy, that its performance will last for at least 1 year after the addition, and that the evolution of color and anthocyanin content and color more generally kept unchanged compared to the control.
Here we see additional results. That was a Syrah wine that was subjected to cold tests with bentonite before the PASP. That increased the stability degree that had been ascertained with the cold test. You see that in both cases you have more unstable wine when compared to Dolcetto in the previous test. After 6 days we have a delta of tartaric acid that reached as much as 0.7, 0.8 grams per liter. In both cases, the addition of polyaspartate in dosage of 10 grams per hectoliter entailed the reaching of stability. This is another test with the same Syrah under clarification and fining treatments with gelatin and with vegetal protein, and the result was good. Also in the case of white wines, we had examples we can offer. This is one case just after the addition and after 6 months. 6 months after the treatment, and also in this case data are confirmed. This picture shows something that you partly already saw with Dr. Triulzi in the previous presentation. Differences pertain to the sediment, and this is not the cold test. This is a preservation for 4 weeks, so it is not the cold test, but it is a preservation test that evidences the good performance of potassium polyaspartate. The test was repeated on several wines. Here you see a series of reds, which are mainly taken from bulk wine at wineries. The majority are from Piedmont, but there are very different wines. You have Nebbiolo, but you also have Croatina. So you have wines which are really different in terms of total anthocyanin content. We did not have problems in terms of modifications, and these are data pertaining to assessment before and after adding polyaspartate. Also, after this addition, we see the concentration of anthocyanins and the color intensity have remained very similar. There is no significant difference. Here is an example with the Syrah wine. This had been treated with bentonite, particularly unstable. We wanted to assess that too in terms of evolution in the bottle during 1 year. using the same process that was applied to Dolcetto. And also in this case, anthocyanins do diminish, but the treatment, differences, derive from the bentonite treatment and not from polyaspartate. The same applies here. Here you see the differences in terms of the doses of bentonite. You see in blue untreated, in red untreated plus PASP. So the couples, the pairs are very similar, which means that there is no effect caused by polyaspartate. We also made tests on the filtrability of wine with a 0.45 micron membrane. You see that it is this filtrability is there, and the trends perfectly overlap in the case of the added wines. This is the white wine, and again, the three things overlap entirely, and that goes for the control as well. Thank you very much for your attention.